Hi guys, my name is Yuan Chen, and I'm conducting an experiment on text classification without using annotated dataset. The motivation of this experiment is that text classification requires annotated data, yet the labeling process can be time-consuming. Therefore, I want to use unsupervised clustering to replace the labeling process. The experiment has two goals. First, find out what's the best encoding algorithm for unsupervised clustering. Second, find out will data augmentation help increase the accuracy. For the implementation, I prepared IMDb dataset, which has two labels, negative and positive. Then I experiment different words encoder to convert word to vector. I use k-mean to cluster the vectors based on the distance between the vectors. The encoder I experiment are TF-IDF, BIRD, and SBIRD. TF-IDF is a method to calculate the score of a word. The higher frequency it is in one document, the more important it is. Yet, the higher frequency it is in all the documents, the less important it is. BIRD encoding is a way to use pre-trained BIRD to extract features from text, but BIRD was never trained for semantic similarity objective. So, someone proposed SBIRD. It's a new way to fine-tune BIRD, train the output of pre-trained BIRD for semantic similarity objective. Take a look at that left bottom figures. SBIRD shows 80% accuracy, which means 80% of the cluster results of SBIRD is same as original datasets. Because SBIRD shows the best accuracy, I treat its clustering result as training data and feed it into BIRD text classification with easy data augmentation. EDA consists of four methods: cinnamon replacement, random insertion, random swap, random deletion. Look at the result without EDA. Both the valid accuracy and the evaluation accuracy are around 85%, which is really good. However, take a look at the result with EDA. The validation accuracy is 99.9%, but the evaluation accuracy is only 83%. This means that EDA's augmented text is too similar to the original text, so the validation data is way too similar to the training data. Hence, we can conclude that easy data augmentation couldn't improve BIRD's accuracy. To further prove that this mechanism can work with other datasets, I also ran the experiment on ece-570, which has four labels. Take a look at the right figure. 0, 1, 2, 3 on the top left means k-means label. 1, 2, 3, 4 below the label is the class index of ece-570. You can see, although not perfect, each label represents one class index. And I fed a clustering result into BIRD. The validation accuracy is 73%. It shows that this mechanism works well with other datasets. It is clear that not using annotated data would decrease the accuracy. However, SBIRD with k-mean with BIRD can build a good text classification model without using any annotated data. The mechanism achieves 84% and 73% valid accuracy in IMDb and ece-570 datasets without using any data augmentation. Moreover, this mechanism is not the most optimized yet. Saying XLNet is a new state-of-the-art in text classification. I believe replace BIRD with XLNet can achieve higher accuracy. Moreover, k-mean works better in lower dimension. Adding PCA or autoencoder might be a good idea as well. This is the end of my presentation. I hope you guys like it.